Video on numericals on artificial neural network and fuzzy logic. So the next question is, use an Adeline network to train AND NOT function with bipolar input and targets. Perform 2 epochs of the training. So the truth table of the AND NOT function is given as follows. For 1, 1 we have output or the target value is -1. For 1 and -1 the output value is 1. So this is the only place where my target is going to be 1. For all the other combinations, my output is going to be -1, -1 and -1. So for 1 and -1, my output is 1. Since in Adeline network, if you recollect the architecture of the Adeline network, we have output coming back as a feedback. So from that we calculate the error, and that error gets added to the training of the network. So initial weights and bias are assumed to be 0.2. So my W1, W2 and bias is 0.2. Alpha is 0.2, which is the learning rate. Now we make a tabular column with different values. So we have x1, x2, these are my input values. 1 is the bias value always remains 1. We have target, for 1 and -1 the output is 1, for all the other values output is -1. Then we calculate y in. As I told you, if these are my input neurons, I have y in. The first part of y in is to calculate the summation value. So this is my y in, and then we have an activation function. So we'll calculate the y in, which is given as b plus x1 w1 plus x2 w2. We know x1, x2, w1, w2 are assumed 0.2. Bias value is also available with me. So I'll calculate the bias y in value. After that, I'll calculate the error value. Error when it exists, when there is a difference between the actual output and the target output. So if there is an error, then I want the network to learn more, and so I'll update the weights. So delta W1, delta W2 and delta B are the change in the weights. W1, W2 and B are the new weights, and this is my error. Error we always take square so that the positive and negative terms does not cancel each other, and we are not left with zero error, even though an error exists. So delta W1 is given by alpha, which is the learning parameter, change or the difference between the target output and the actual output, and x1. Similarly, I'll calculate delta W1, delta W2 and delta B, delta bias, and then I'll calculate the new weights. W1 new, W2 new and new bias is equal to old bias plus delta bias. Similarly, we have W1 new is W1 old plus delta W1, and W2 new is equal to W2 old plus delta W2. Till where you will carry out this training, the question clearly mentions you have to perform this up to 2 epochs. So this is my first epoch when we have all the 4 input combinations. This makes 1 epoch, one more epoch of 4 input values, and I will complete the numerical. My aim here is to reduce the error as much as possible so that the network makes less mistakes and learns more. So this completes this numerical. Thank you for watching.